Hari Om. Hello everyone, I am Sri Jyoti. Welcome back to my channel. In this video, we are going through some case study questions based on relations and functions. First question, Sherlyn and Danju are playing Ludo at home during COVID-19. While rolling the dice, Shirley's sister Raji observed and noted the possible outcomes of the throw every time. Belongs to the set 1, 2, 3, 4, 5, 6. Let A be the set of players while B be the set of all possible outcomes. A is equal to set SD, B is equal to set of 1, 2, 3, 4, 5, 6. First question, okay, based on this information. First question, let R from B to B be defined by R is equal to set of ordered pair XY such that Y is divisible by X is dash. Here, okay, so first of all, let's write the elements of the relation, given relation. What is the relation? Ordered pair XY, Y is divisible by X. That means here in ordered pair, all the second element should be multiple of first element. That is, see, Y is divisible by X, right? So here the relation is from B to B. What is the set to B? B is nothing but 1, 2, 3, 4, 5, 6. So 2, 1, 2, 3, 4, 5, 6, right? So here, first of all, let's write the elements of the relation, given relation. Therefore, R is equal to, here, Y is divisible by X, right? So here we can write 1, 1 because 1 is divisible by 1, right? 2, 2, 2 is divisible by 2, right? Similarly, 3, 3, 4, 4, 5, 5, 6, 6. Okay, next. 1, 2, 2 is divisible by 1, right? 1, 3, 1, 4, 1, 5, 1, 6. Then after that, 2, 1 is not possible because 1 is not divisible by 2, right? So 2, 4, 4 is divisible by 2, right? Next, 2, 6 is not possible. Yes, 2, 6 because 6 is divisible by 2, right? Then 3, 4 is not possible. 3, 6, right? Okay. Now, let's check whether this relation is an equivalence relation or not. For equivalence relation, it should be reflexive, symmetric and transitive, right? For reflexive, here, see, for reflexive, we know that A, ordered pair AA should be belongs to R, okay? So here, see, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 belongs to R. Here, B is nothing but 1, 2, 3, 4, 5, 6. Therefore, in this relation, for reflexive, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 should be in this relation, right? So here, it is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 belongs to R, okay? Therefore, this R is reflexive. R is reflexive, right? Then, for symmetry, we know that symmetry means, see, let's take one element, okay, 1, 2. 1, 2 belongs to R. Then 2, 1 should be in this R for symmetry, okay? So here 1, 2 belongs to R, but 2, 1 does not belong to R, right? 1, 2 belongs to R, but 2, 1 does not belong to R. Therefore, here R is not symmetry. Next, for transitivity. Here we have already studied, right? For transitivity, if XY belongs to R and YZ belongs to R, then XZ belongs to R. Okay? If XY belongs to R and YZ belongs to R implies XZ belongs to R, then the relation is transitive, right? So here let's take, okay, let's take 1, 2, 1, 2 belongs to R and next let us take 2, 4, okay, 1, 2 belongs to R, 2, 4 belongs to R. Then for transitive, 2, 4 should be belongs to R. See, 1 2 belongs to R, 2 4 belongs to R, and 2 1 4. 1 4 is there, right? Yes, 1 4 belongs to R. Right? See, we have taken one element, 1 2 and 2 4 belongs to R. Then this implies 1 4 belongs to R. 1 4 belongs to R. Right? Therefore, next let's take another element. Okay, 1 3. 1 3 belongs to R and 3 6. 3 6. 1 3 3 6 belongs to R. And 1 6. 1 6 should be in this R. Right? For transitivity. See, 1 3 3 6. 1 6 belongs to R. Right? Therefore, this R is transitive. Okay? R is transitive. Therefore, the answer is R is reflexive and transitive but not symmetric. Okay? R is, this relation, given relation is reflexive and transitive but not symmetric. Second question, Raji wants to know the number of functions from A to B. How many number of functions are possible? Here, number of elements of A, that is n of A is equal to 2 and number of elements of B is equal to 6. Okay. Now, number of functions from A to B. Here, relation, that is from A to B, it is already given, right? Number of functions from A to B is number of functions from A to B is equal to, A to B is equal to number of elements of B whole raised to number of elements of A. Note it down. Number of functions from A to B is equal to number of elements of B, okay, number of elements of B whole raised to number of elements of A. Here, what is the number of elements of B? That is n of B, 6, right? So, 6 raised to number of elements of A is 2, 6 square. Okay, therefore, number of functions from A to B is 6 square. Third question, let R be a relation on B defined by R is equal to 1 2, 2 2, 1 3, 3 4, 3 1, 4 3, 5 5. Then R is dash. Options are symmetric, reflexive, transitive, none of these. Okay, let's take. First of all, reflexive. For reflexive, see it is given R be a relation on B. These are the elements of B, right? So here for reflexive, 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. These all elements should be in this set, in this relation, right? But here only 2 2 belongs to R, but and remaining 1 1, 3 3, 4 4, 5 5, 6 6 are not contained in this set, right? Therefore, this relation is not reflexive. Okay, it's not reflexive. Next, for what about symmetry? Okay, let's take. See, 1 3. Let's take any element. 1 3 belongs to R, right? 1 3 belongs to R. Next, for symmetric, 3 1 should be in this set, right? Yes, 3 1 belongs to R. Next, let us take 3 4. 3 4 belongs to R. 4 3 belongs to R, right? Next, 1 2. 1 2 belongs to R. 2 1. 2 1 should be in this set, right? For symmetry. So 2 1 does not belong to in this set, right? So 2 1 does not belong to R, right? Therefore, this R is not symmetry. Okay? Because 1 2 belongs to R, but 2 1 does not belong to R, right? Therefore, it is not symmetry. Next, for transitive. For transitivity, we have to take two elements from the set. Okay, 1 3, then 3 1. So 1 3 belongs to R, 3 1 belongs to R. So 1 1 should be there, right? So 1 1 does not belong to R, right? So next, okay. Now from this one example, we can say this R is not transitive. Okay, why? Because see 1 3 and 3 1 belong to R, right? But 1 1 does not belong to R. Therefore, R is not transitive. So the answer is none of this. So next question, based on the above information, Rajiv wants to know the number of relations possible from A to B. How many number of relations are possible? Here, how many number of relations? Okay. In previous question, we have already found the number of functions, right? So how many number, that is number of functions from A to B is number of elements of B whole raised to number of elements of A. So here, what is the number of relations from A to B? Okay, number of relations from A to B is equal to 2 raised to number of A into number of B. Number of elements of A into number of elements of B. Okay. Number of relations from A to B is 2 raised to number of elements of A into number of elements of B. That is number of elements of A 2, right? There are 2 elements in the set A. There are 6 elements in the set B, right? Therefore, 2 raised to 2 into 6, that is 2 raised to 12. So here, number of relations from A to B is 2 raised to 12. Number of functions from A to B is number of elements of B whole raised to number of elements of A. That is 6 raised to 2. Okay. Next question, let R from B to B be defined by R is equal to 1 1, 1 2, 2 2, 3 3, 4 4, 5 5, 6 6. Then R is dash. Options are symmetric, reflexive and transitive, transitive and symmetric, equivalence. Okay, so first of all, reflexive. Here, this R containing 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. Right? So all these elements are in this set R, therefore R is reflexive. Because here relation from B to B, right? Elements of B is 1, 2, 3, 4, 5, 6. For reflexive, all these elements 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 should be containing in this set R, right? So, okay, so here R is reflexive. Then what about symmetric? See, take this element 1, 2. 1, 2 belongs to R, but 2, 1 does not belong to R, right? Therefore, R is not symmetric. R is reflexive but not symmetric. Okay. Next, what about transitive? Here for transitivity, see we have only these 2 elements, right? So 1, 2, 2, 2. Okay, 1, 2 and 2, 2 belong to R. Then 1, 2 should be in this R. 1, 2 is in this R, right? Therefore, it is clear that R is transitive. So R is reflexive and transitive. R is reflexive and transitive. Therefore, the correct answer is B. Next question. Archana visited the exhibition along with her family. The exhibition had a huge swing which attracted many children. Archana found that the swing traced the path of a parabola as given by y is equal to x square. So here the first question based on the given information, let f from R to R be defined by f of x is equal to x square is dash. Options are neither surjective nor injective, B surjective, C injective, D bijective. So surjective means onto function. Surjective function, onto function. Injective function means one function And bijective, what is bijective? If a function is 1, 1 and on 2, then the function is called bijective function. Okay. So here the function is f of x is equal to x square. Okay, let's check whether it is 1, 1 or on 2. Okay, 1, 1 and on 2. So here we know that it is clear that, see, f of 1 is equal to f of minus 1 is equal to 1. Right? F of 1, that is 1 square, is 1, and f of minus 1 square is also 1. So here, see, our function is from R to R, set of real numbers to set of real numbers, right? So here, codomain all the set of real numbers and domain is all the set of real numbers, right? So here, this 1, okay, this 1 in the codomain has two pre-images, right? 1 and minus 1. Therefore, this function is not 1, 1. 1, 1 function means, so here that is f of x is equal to f of y, that implies x is equal to y. Right? So here this 1 has more than one pre-images. See, this 1 has, this 1 and minus 1 are the pre-images of 1. Right? Therefore, this function f is not 1, 1. Okay? Not 1, 1. 1, 1 means injective. Okay? So, f is not injective. Now, what about surjective? Onto function. See here, f of x is equal to x square. Right? So, here in the codomain, set of codomain, see some elements are negative elements. Right? That means minus 2. Okay? Because our function is from f from R to R. Set of real numbers means minus 2 is included. Right? So, minus 2 belongs to R. Right? That means this minus 2 belongs to codomain. Okay. But here, so what is the pre-image of minus 2? What is the pre-image of minus 2? See, our function is nothing but x square. Okay. Suppose it is a to b. Okay. Function is from f of x is equal to x square. Okay. 1 minus 1, 2 minus 2, etc. Okay. So here also 1 minus 1, 2 minus 2, etc. See here, this minus 2, so what is the pre-image? That is square root of minus 2. Right? Because our function is f of x is equal to x square. It is x square. This 1 square 1. Minus 1 square minus 1. Right? So 2 square 4. Minus 2 square 4. So here, what is the pre-image of minus 2? Square root of minus 2. Right? So square root of minus 2 is a complex number. Okay, not real number. But here in this domain, only real numbers are there. Right? Only real numbers contained in this domain. Right? Therefore, these minus elements, okay, minus numbers. So here this minus 2 has no pre-image. Okay, this minus 2 has no pre-image. Therefore, we say this function is not an onto function. That is, this function is not surjective. Okay. Therefore, here it is clear that the function is, this given function is neither surjective nor injective. So, it is the correct answer. Okay. Because it is not 1, 1 and not onto. Okay. Because this 1 has two images. Therefore, this function is not 1, 1. And some negative elements, okay, not some, all the negative elements, that is negative numbers, have no pre-images. Therefore, this function is not onto. Okay. Therefore, it is neither surjective nor injective. Second question, similar question. Okay. Here, let f from n to n, set of natural numbers to natural numbers, be defined by f of x is equal to x square is dash. Surjective but not injective. Surjective, injective, bijective. Okay, surjective means onto, injective means 1, 1. Bijective means both surjective and injective. Okay. So here, first of all, our function is f of x is equal to x square. Okay. And here, domain is the set of natural numbers. Codomain is the set of natural numbers. Right? F of x is equal to x square, function from n to n, That is natural numbers starting from 1, 1, 2, 3, 4, etc. 1, 2, 3, 4, 5, etc. Okay. Now, what is the function? F of x is equal to x square. Then what is the image of 1? F of 1 is 1 square, that is 1. 2 square, 4. 3 square, 9, etc. Okay. So here, see, this 1 has only one preimage and 4 has only one preimage. Okay. So here all the square numbers have only one preimage. Okay. Therefore, this function is 1 function. Then what about own 2? See here, clearly these 2. Okay, let's take 2. This 2, what is the preimage of 2? Square root of 2. Right? Because function is f of x is equal to x square. Okay. So, square root of 2 is the preimage of 2. But here, the square root of 2 is not a natural number. It's an irrational number. Right? So, it does not exist in this domain. Okay. Therefore, this 2 has no pre-image in this domain. Therefore, we can say this function is not an onto function. Okay. Because this 2, 3, 5, 6, all these numbers have no pre-images in this domain. Okay. Therefore, this function is injective, that is 1 function, but not onto. So, this function is an injective function. It is the correct answer. Next question. Let f from 1, 2, 3, etc. to set 1, 4, 9, etc. be defined by f of x is equal to x square is dash. So, here say domain is the set of 1, 2, 3, etc. 1, 2, 3, 4, 5, etc. Okay, that is set of natural numbers. And codomain is the 1, 4, 9, etc. Okay. So, here let's check whether it is 1, 2 and 1, 1. Okay. See here, 1 image of 1, 1. Right. Our function is f of x is equal to x square. Image of 2, 4. Image of 3, 9. Image of 4, 16. Right. So, here 4 has only one preimage. 1 has only one preimage. 9 has only one preimage. So, all the elements of codomain has only one preimage. Right. Therefore, it is 1, 1. That is, it is injective function. Okay. It is injective function. Then, what about onto? What about surjective function? So, here, see, all the elements, here the elements are nothing but squares, right? Perfect squares. Okay. So, here all the elements of this codomain, okay, elements of codomain have preimages in the domain, right? So, let's take 25. Square root of 25, 5. It is in the set of domain, right? And 16. Square root of 16, 4. Okay. 81. So, 81, square root of 81, 9. So, here all the elements of codomain have preimages in the domain. Therefore, this function is 1, 1 and onto. That is, this function is surjective and injective. Okay. Surjective and injective. That is, if a function is both surjective and injective, then that function is called bijective function. Okay. Therefore, this function is bijective. Next question. Let f from n to r be defined by f of x is equal to x square. Range of the function among the following is dash. Very simple. See, here given function is n to r. Domain is the set of natural numbers and codomain is the set of real numbers. Okay. So, here we have to find the set of range. Okay. That means, see here all the range elements of range belongs to R. That is in the codomain. Okay. So, let's find, see, set of natural numbers. So, domain is the set of natural numbers starting from 1, right? So, what is f of 1? F of 1, 1 square, 1. F of 2, 4, right? f of 3, 3 square, 9. f of 4, 4 square, 16, etc. Right? So what is the range? Range of the function is equal to 1, 4, 9, 16, etc. So these are the elements of range. Range of this function. Okay. So it is the correct answer. Next question is, the function f from z to z defined by f of x is equal to x square is dash. Here, domain is the set of integers, codomain is the set of integers. In integers, all the negative numbers are included, right? So here, see, it is clear that f of minus 1 is in this domain, right? Because it is set of integers. So f of minus 1 is 1, minus 1 square, 1. Our function is f of x is equal to x square. What is f of 1? That is also 1. So here, this 1 has two preimages, right? Therefore, this function is not 1, 1. That is, this function is not injective. Then what about onto? See here, in codomain, negative numbers are there, right? So what is the preimages of negative numbers? Complex numbers, right? That is, suppose let's take minus 2. Minus 2 belongs to z. That is in the codomain, okay? And what is the preimage of minus 2? Square root of minus 2. It does not exist in the domain, okay? Because square root of minus 2 is the complex number. So, and here one more example. See, 2 belongs to z in the codomain. What is the square root of 2? It's an irrational number. But our domain is the set of integers. Okay? Integers means negative whole numbers, positive whole numbers. Right? With a 0. So here, this 2 has no pre-image in the domain. Therefore, this function is not onto. This function is not neither 1, 1 nor onto function. That is, this function is neither surjective nor injective.